Alright, let me flip my laptop and I will show you guys how to do this one. Aha! Lovely, it turned out just the way I wanted it. Okay, so scenario 6. This is my third time doing it. Evidently the first time I did it, I accidentally plugged something in the wrong way in my calculator. So when I was going through it the second time showing you guys, I realized there was something, the numbers were very off. So we're going to start all over again. So we're going to calculate the drug elimination half-life, T half-life, for this clinical trial. They administered a 5 milligram single IV bolus dose to a group of patients, and they drew blood, want to figure out what the concentrations are initially. So first off, we need to find Ke to find T half-life. And the way that we find that is using, let me pull it up, this equation. So Ke equals ln over C1 over C2 and then over T1 minus T2. So we're going to use 4 and 8 and 15 and 2.1. So excuse my chicken scratch, I'm in a rush because it's now really late at night and I want to go to sleep. Okay, and you should enter that into your calculator and you should find 0.4411. So that is your elimination rate constant. So then you have to find the T half-life, which is ln of 2 over Ke, and that should equal 1.571 if I've done this correctly. Okay, so you found out that is almost 1 1/6 hours of the half-life for number 10. Alright, so that's number 10. I think I should switch colors for these, because these ones there's 5 of them. So, 11, calculate the initial drug concentration. So the way that we're going to do this is we're going to use, I'll just erase this because I really don't want it in the way. C at a certain time is equal to the concentration 0 at e to the negative Ke T. So we have, let me erase this. We have 8. And that's the one that we're going to use. Dr. What's his face? He went through this during recitation, but because recitation didn't record, I'm recording this and showing you guys how to do it. So, C8 equals 2.61 micrograms per liter. And that is equal to CO e to negative 0.4411 times 8. Sorry, it's getting cut off over there. So this is also the same. This is the same as writing it as 2.61 micrograms per liter over e to the negative 0.4411 times 8. When you plug that into your calculator, you should find that CO is equal to 88957 micrograms per liter. Alright, so that's for initial drug concentration. Now, let me change colors. Ooh. No. There. Red, we're going to find VD. Sounds like a bad venereal disease, but it's not. It's just volume of distribution. Don't be scared. Alright, calculate the volume of distribution for this drug. So volume of distribution, we're going to use this equation. I can actually show you on the thing. We're going to use this one, initial drug concentration. But we're going to use it to find VD. So it's concentration 0 equals drug over volume of distribution. The drug they gave us is 5 milligrams, but the concentration we have initially is in micrograms, so we're going to change that into micrograms really quickly. So you're going to multiply 5 times 1,000, so you're going to get 5,000. That's all you're doing. So don't get scared when you see 5,000. It's nothing to be scared of. And so when you move that around, what you'll do is you'll take 5,000 divided by 88.957, and you'll find that volume of distribution is 56.2 liters. Okay? Got it? I'm going to move on to the next one. Alright, so calculate the area under the curve from 0 to 4 hours. So area under the curve 0 to 4 is equal to the concentration 0 plus the concentration at time 4 over 2 times 4 minus 0 hours. So this is 88.95 plus that nice 15.24 over 2 times 4. When you plug that into your calculator, you should get 208.38 micrograms times hour over liter. Alright, and then I'm pulling that from, let me find the equation, just give me a second. Where is AUC? There it is. That's where I'm pulling it from. So I'm just using the trapezoidal method, and I believe the prof went over that in class, or recitation, which you guys all missed. But he did not, you guys aren't doing limits, but I can do a little bit of a quick one just to show you guys limit. So AUC, was it 12 to infinity? 12 to infinity and beyond. That looks like it's an 8. So the way that I used to do these, you take the limit, and so as the limit of as x approaches infinity, the concentration of the drug approaches 0. So that's what you're just not infinity, 8, 0. So what you essentially do, so essentially you're just trying to find this all the way over here. But honestly, I would basically do it all by limits and stuff, and then I would enter just ridiculous numbers into this equation just to double check. So when they eventually teach us how to do that, I'm not going to teach you tonight. Just keep that in mind, that just remember this equation and just enter ridiculous numbers in it, and you'll be fine. You know, there's always ones to double check. There is one later in here that I don't believe I got the right answer, but when I double checked it, I figured it out just by plugging and chugging. All right, so I'm going to move on to the next section and stop recording. No, there we go.